You may think air fryers are new technology, but what if I told you they've been around since the 1940s? Of course, that's old school, so if you're wondering how modern air fryers are made, then stick around till the end, because we'll be breaking everything down step by step. Step 1. Planning and designing. Before a single screw or wire gets touched, the air fryer starts life on a computer screen. This is where the engineers roll up their sleeves and start sketching ideas. They're not just asking, how do we make this cook food? They're also asking, what do people want it to look like sitting on their kitchen counter? Because, let's be honest, nobody wants an ugly, clunky box next to their toaster. So they brainstorm, toss ideas around, and eventually agree on what this thing should do and how it should look. Then comes the 3D modeling stage. Imagine a super detailed digital blueprint where you can spin the fryer around, zoom in, and even test how parts will connect. This is the stage where they decide details like where the buttons will go, how big the basket should be, what the screen looks like, and even which shade of black or silver is going to make it look sleek. The coolest part is that they can actually simulate problems before they happen. If the airflow looks wrong, they'll catch it here. And if the basket doesn't fit just right, they'll fix it on the model before wasting real materials. Basically, this phase saves them from expensive mistakes down the road. It's slow and meticulous work, but it has to be. Rushing this step would mean design flaws, safety risks, and a product nobody wants. So, while it looks like they're just staring at screens, this is where the good idea actually starts becoming something real. Step 2. Sourcing and gathering the materials. Once the design is locked in, it's time to start collecting all the materials needed to make the air fryer. Think of it like assembling the ingredients for a recipe. You can't bake a cake without flour, and you can't build an air fryer without plastic, metal, glass, wires, and heating elements. The outer shell needs durable plastic, designed to handle heat without melting. The basket inside is made with food-grade metal, tough enough to handle constant use and high temperatures. As for the touchscreen, it is made from reinforced glass that won't crack the first time you tap it a little too hard. Then there are the wires and the heating element, the parts that basically make this box more than just a container. But here's the thing. The air fryer company doesn't make these materials themselves. They source them from specialized suppliers all over. But not just any supplier will do, as each part has to meet strict standards. The plastic has to resist heat, the metal has to be safe for cooking, and the wires need to handle electricity without overheating. Everything gets tested and inspected before it's allowed into the factory. There's even a team dedicated just to quality checking. If a single batch of defective parts slips through, it could ruin hundreds of fryers, and no company wants that kind of disaster. So every screw, sheet of plastic, and coil of wire is carefully inspected. Only the best stuff makes the cut. So once all the components are gathered and approved, they're laid out, ready for the next stage, which is turning piles of parts into something that actually looks like a fryer. Step 3. The outer shell takes shape. With the raw plastic on hand, it's time to give the fryer its outer shell. This is the part you see first, so it has to look good. The process starts with heating plastic pellets until they're a hot, gooey liquid. That liquid is then injected into giant steel molds shaped exactly like the fryer's body. It's kind of like pouring batter into a cake pan, except way hotter and far less edible. Once the liquid fills every nook and cranny of the mold, it's quickly cooled down until it solidifies into a hard shell. And when the mold is opened, you've got the recognizable frame of the air fryer. This method is called injection molding, which gives the fryer that smooth, glossy finish. But it doesn't stop there. The shells are carefully trimmed to remove any excess plastic, almost like giving them a haircut. Then they're inspected. If there's a dent, a scratch, or a tiny crack, that piece is tossed out. After all, nobody wants to buy a brand new fryer that looks secondhand. Finally, the shells get cleaned and polished so they're shiny and ready for assembly. This whole step happens surprisingly fast, which is why factories can crank out thousands of fryer shells in a short amount of time. But even though it's quick, it's still one of the most important stages. Because let's be real, if the fryer doesn't look good on the outside, you probably won't even care about how well it works on the inside. Step 4. Constructing the heating element. Now we move from looks to power. And when it comes to power, the air fryer's secret weapon is its heating element. This is the coil of metal wire that gets blistering hot and makes cooking possible. Without it, your fryer is just a fancy-looking storage box. The element starts as a straight piece of special metal wire, chosen because it can handle extreme temperatures without breaking down. Machines then bend and curve the wire into a perfect coil. But the spacing of the coil isn't random. Each loop has to be measured precisely so the fryer heats evenly. If it's too close together, it overheats, and if it's too far apart, your fries will cook unevenly. This process is mostly automated, controlled by computers that ensure every coil is exactly the same. But humans still step in to check for flaws, because one bad element could mean a fryer that fails on day one. The ends of the coil are also prepared carefully so they can connect to the fryer's circuitry later. This connection has to be rock solid. If it's loose, sparks could fly, literally. Durability is everything here. These coils are expected to heat up, cool down, and repeat that cycle thousands of times over years of use. Any weakness in the material or shape could cause it to fail early. That's why this step is done with such precision. Step 5. Assembling the internal components. This next stage is where the idea really starts to look like an air fryer. Up until now, it's just been separate shells, coils, and wires. But in this step, all the puzzle pieces come together. The heating element is installed inside the shell first, followed by the fan. Now the fan is just as important as the heater, as it blows the hot air around, making sure your fries get crispy instead of soggy. Both the fan and the heater are mounted on the main circuit board, which acts like the fryer's brain. Next comes the wiring. Each wire has to be routed neatly and soldered in place so that electricity flows exactly where it should. But this isn't just about looks, because sloppy wiring can cause shorts, sparks, or even fires. So everything is double-checked by skilled technicians, and often computers, to make sure every connection is perfect. The fan also has to be mounted tightly, because if it wobbles even a little, it makes noise and stops circulating air properly. Imagine expecting crispy wings and instead getting half-burnt, half-cooked meat. By the end of this stage, what was once an empty plastic shell now has a brain, a heater, and a fan. It's no longer just a box of parts, it's officially a machine. From here, the fryer is nearly ready to take on its final form. Step 6. The control panel and screen. Now we get to the part everyone notices first. I'm talking about the face of the air fryer. This is where the control panel goes on. A small touchscreen is fitted in, with buttons neatly placed around it. Behind the scenes, tiny wires run from the screen to the main circuit board, so when you tap a button, the fryer actually listens. That's how you set the temperature, cooking time, and check your settings on the screen. This step has to be done with absolute precision. If a single wire is off, the whole screen won't work. The buttons also have to feel just right. They have to be clicky, responsive, and not wobbly. Workers test them one by one to make sure they respond instantly. The screen also has to be secure and easy to read. Imagine if it was loose or tilted. It wouldn't just look bad, it would ruin the whole user experience. And since this is the part you'll use the most, the team gives it extra attention. They carefully align the screen with special tools, test the buttons, check every wire, and polish the surface so it looks flawless. This might seem like a small detail, but it's what makes the air fryer simple, friendly, and enjoyable to use. Step 7. Tightening the screws. At this point, all the pieces are ready. The inner basket is dropped into place. The heating element and fan are already secured inside, and the sleek outer shell slides over everything. Then comes the part where screws are tightened, panels are aligned, and little by little, a pile of separate parts turns into a real air fryer. Workers use small drills and screwdrivers to lock everything in place, making sure each piece fits snugly without pinching wires or scratching the shell. Every screw has a designated spot, almost like a giant 3D puzzle. When done right, it's seamless, as you can't even tell where one piece ends and another begins. This is the moment the air fryer finally takes its full shape, looking just like the one you'd spot on a store shelf. It's quick, it's precise, and it's the final build before the big test. Step 8. Quality control and testing. Now, even though the air fryer looks finished, it isn't ready for your kitchen just yet. The reason is simple. It has to survive a series of tough tests first. It's plugged in, the fan is switched on, and the heating element is fired up. Every button and every touchscreen tap gets checked. Testers listen for strange rattles, watch for warning lights, and make sure screws are secure. And don't think this stage isn't just about performance alone, because it's about safety. The fryer has to pass strict standards before it can leave the factory. That means precise temperature checks, electrical tests, and safety inspections to make sure it won't overheat or cause problems in your home. Specialized machines are even used to detect tiny flaws you'd never notice. If something doesn't pass, the fryer goes back for fixing. And in some cases, it gets scrapped altogether. Only the units that work perfectly make it through. Yes, it's strict, but that's how they guarantee that when you use it at home, it's reliable and safe. Step 9. Final cleaning and polishing. Once the fryer clears all its tests, it still needs one last touch. And that's a good, thorough cleaning. Any smudges, fingerprints, or tiny bits of dust get wiped away, thanks to the workers who use soft cloths and special cleaning products to polish the shell until it shines. They even get into the small corners to make sure everything looks flawless. This might seem like a small step, but presentation matters. Nobody wants to unbox a brand new appliance that looks used. So a spotless, glossy finish gives the fryer that fresh out-of-the-box feel. It's the final beauty check before packaging, ensuring the product not only works perfectly, but also looks like it was made just for you. Step 10. Packaging and shipping. Finally, the fryer is ready to head out into the world. It's carefully packed into a sturdy cardboard box along with the inner basket, racks, and a user manual to help you get started. But the packaging isn't just about looks. It's designed to protect the fryer as it bounces through warehouses, trucks, and store shelves. Once boxed, fryers are stacked on pallets, wrapped for safety, and loaded onto trucks by forklifts. From there, they're shipped to warehouses and eventually to the stores where you'll find them. The box shows the brand name, a picture of the fryer, and all the details you need to know. And by the time you see it on the shelf, it's already been through a long journey from design to testing to polishing. So that's how modern air fryers are made. But how were they manufactured back in the 1940s? Let's find out. How old air fryers were made before the modern era. Back in the 1940s, the very first version of what would later inspire the modern air fryer was created by an American inventor named William L. Maxson. However, he wasn't setting out to make a trendy kitchen gadget for families. His focus was actually on solving a problem for airlines and the military. Maxson came up with something called the Maxson Whirlwind Oven, a bulky 35-pound machine that used circulating hot air to heat pre-prepared meals. It wasn't sleek or compact, but it was the first real attempt at cooking food with hot air instead of dunking it in oil. Now, don't picture anything close to the stylish touchscreens and digital timers we see today. Maxson's invention was all heavy metal, noisy fans, and heating coils that looked like something pulled out of an old toaster. Instead of smooth electronic circuits, it had hand-soldered wires and big clunky switches that gave a loud click when you turned them on. The body was steel, bent and welded by hand, while the fan inside was powered by a basic electric motor that pushed hot air around the chamber. It was rough, industrial, and loud, but it worked. Now the way they put these things together was completely old school. Workers used drills, screwdrivers, and plenty of elbow grease to align and secure every part. There weren't sophisticated testing machines either. They'd literally plug it in, see if it heated up, then toss in some food and watch what happened. If it cooked, it passed. Simple as that. Of course, Maxson's oven wasn't perfect. The food didn't come out as crispy as it does in modern air fryers, and at 35 pounds, it definitely wasn't something you'd keep on your kitchen counter. But what he proved was groundbreaking. That hot air could cook food in a way that mimicked frying, just without drowning everything in oil. That idea, which was born out of wartime necessity and airline catering, ended up being the seed that grew into the air fryers we use today. It was clunky, experimental, and way ahead of its time. But William L. Maxson's old-school invention set the stage for one of the most popular kitchen gadgets in the world. So now that you know exactly how air fryers are made, subscribe to my channel if you'd like to learn how other popular gadgets are made from scratch. Thanks for watching. So what do you think about air fryers are made? And if you'd like to discover how things are made from scratch, subscribe to our channel right away, and we'll see you in the next one.